Okay, so now we're going to solve the equations. So they're still quadratic in form. So for solving the equations, let's say I have 5x to the fourth minus 9x squared plus 4 equals 0. So again, it's very important. We're going to substitute. So u equals x squared. Remember, x to the fourth is x squared squared. So now I have 5u squared minus 9u plus 4 equals 0. And so we're going to use our x method. So I have negative 9 there. I've got 20 there. So we need to find two numbers. So negative 5 and negative 4 will multiply to be positive 20 and add to get you negative 9. So again, a is not 1. So I do have to do the whole drawn out method here. So I have 5u squared minus 5u minus 4 plus 4 equals 0. I need to group these. So here my common factor is 5u, and I'm left with u minus 1. And here, what? I have negative 4, and then I'm left with u minus 1. So I end up with 5u minus 4 times u minus 1 equals 0. Now here's the catch. You cannot solve until you have substituted back. So we have to put that back. So let's now substitute. So we're going to go on to the next slide. So I had 5u minus 4 and x minus 1 from the previous slide. And we know that u equals x squared. So now I need to substitute 5x squared minus 4. Oops, I just realized I wrote an x instead of a u here. Lord have mercy. Sorry if you got confused. That should be u minus 1 from the previous page. And then I have x squared minus 1. And that equals 0. Okay, what you do want to notice here, that this is a difference of squares. Okay, so you want to kind of keep your eyes out for that. So 5x squared minus 4, that's not a difference of squares or anything here. But x squared minus 1 is a difference of squares. Remember that you have your two binomials, a plus minus, and you take the square root of your first term, so the square root of x squared is x, and the square root of your second term, so the square root of 1 is 1. Okay? Now you're going to set each of these equal to 0 to solve. So here I get 5x squared equals 4, and then I have to divide by 5. So I get x squared equals 4/5. I'm going to actually take this over here. So then you actually need to take the square root of both sides. So I get x equals positive square root of 4 over square root of 5 and negative square root of 4 over square root of 5. So I'm going to actually need to simplify that. So I'm going to put this on the back burner for a moment, and I'm going to handle this part here. So again, I have x equals the positive square root of 4 over square root of 5 and the negative square root of 4 over the square root of 5. I also had from over here x plus 1 equals 0 and x minus 1 equals 0. I'll solve those here in a moment. So the square root of 4 is 2. But I don't know, I can't take that square root of 5. So that means I need to rationalize it. Okay, so remember you multiply by whatever is in the square root. And it has to be in the numerator and denominator. So then I'm going to multiply across. So I get 2 square root of 5 all over. And remember the square root of 5 times the square root of 5 is going to be positive 5. And then I'm going to just have the negative version of that. So instead of actually doing all the work for this, I've got it already, so I'm good to go. And then I've got 2 more. So here I'm going to solve. I get x equals -1, and here I get x equals 1. So I get -1 and 1. So those are my 4 answers. And the reason why I have 4 answers is because here I started out with x to the 4th. So you should have 4 answers for your equations when you solve. Okay, so I have 2 square root of 5 over 5, -2 square root of 5 over 5, -1, and +1. Let's look at another one where we're going to solve. So I have 3x to the 5th minus 2x cubed minus 8x equals 0. This right now, if you notice, this is not 4 2 and nothing. It's 5 3 1. So that means I can factor out a GCF. You always want to look for that where you need to factor out a GCF. And that happens with sum and difference of cubes as well as this. It can happen too. So here I'm going to factor out an x, and then I have 3x to the 4th minus 2x squared minus 8 equals 0. So now I'm going to make my substitution. U equals x squared. And so now I'm going to substitute. So this is x times 3u squared minus 2u minus 8 equals 0. Now I'm going to do my big ol' x method. So here I have -2. Here I have -24. So I have -6 and +4. Now this x here, it just stays along for the ride, okay? But I do need to, because a is not 1, I do need to do my whole little brouhaha method. So I get 3u squared minus 6u plus 4u minus 8 equals 0. So here my GCF with 3u minus 6u is going to be 3u. And I get u minus 2. Here my GCF is 4, and I get u minus 2. So then I end up with x times 3u plus 4 times u minus 2, and that equals 0. At this point, I need to make the substitution back. So we had 3u plus 4. We had u minus 2 equals 0. And remember, u equaled x squared. So then I need to substitute back in. So the u was x squared. So I'm going to replace that. I'm going to check here because I see subtraction, whether that's a difference of squares, and it's not because 2 is not a perfect square. So what I'm going to do is I'm going to set each of these equal to 0 to solve. Okay, so, well, this one's pretty easy. I already have that x equals 0, so that was nice. Here, I think I'm going to see some fun. Very nice. When I do all of that and take the square root, I get some craziness happening. I'm going to work over here to be able to do that. So, we know we're going to have the positive and negative version of of the square root of -4 over the square root of 3. So the square root of -4 is 2i. So I have 2i over the square root of 3. That means I need to multiply both of those by the square root of 3. So I get 2i square root of 3 all over 3, and then -2i square root of 3 all over 3. That was a good time, huh? And then what I'm going to do is I'm going to solve this guy. So I take the square root, and x equals the positive square root of 2 and the negative square root of 2. So I've got that. Notice I have 5 answers here, and that is because we started out with the x to the 5th. Okay, so then my final answer here is x equals 0, because that was from here. And then I have 2i square root of 3 over 3. and the negative 2i square root of 3 over 3. And then I have this final one where I have the square root of 2 and the negative square root of 2. So those, all 5, are my answers. Okay, so now we have seen how to solve disguised quadratics. And one other thing, one little lanyap thing, it's not quite like a disguised quadratic. However, this is where I felt would be most appropriate to put in. And it's like an ACT question. So what they want you to do is solve for x. So I have x to the 5th plus 125 equals 72. Notice all I have is this x to the 5th, so I'm going to isolate it by subtracting 125. And I get negative 53. Now, in order to get the x alone, I have to take the 5th root. So let me walk you through on your graphing calculator how to take the 5th root. So on the calc, first you have to type in your root, okay, which in this case it's 5. And then you hit math. Let me actually kind of move this over. I'm going to write it here. So on the calculator, you have to type in your root, whatever your root is. You have to type that in first on the home screen. And in this case, it's 5, so you're going to type in a 5. Then you have to hit the math button. And then hit number 5, because that is, you'll notice that it's like an x with a radical. And that's because you're going to actually replace that x with whatever your root that you typed in. And then once you press 5, it should actually bring you back onto the home screen, and you should see right now that you have a 5th root. And then I want you to type in negative 53. It's okay to type in a negative. If you get an error, obviously it can't be a solution. But in this case, you will get a solution. And I want you to round to the nearest hundredth. And when you do, you get negative 2.21. So this is just something that you'll see on the ACT that I just wanted to address, especially with your graphing calculator. So now at this point, you have all of the notes for solving disguised quadratics, and you will do your assignment in class the next mod.